just going to look at complementary trigonometric ratios. Now, you might remember that complementary angles, basically they add up to 90. So this word complementary trigonometric ratios, the complementary part, you've seen this word before, and all that it means when you're looking at complementary angles, they add up to 90. So complementary trig ratios, it means that if you have one trig ratio that is theta and the other trig ratio that is minus theta, then there are certain trig ratios that will be exactly the same. But that's basically sine of 90 minus theta will be exactly the same as cos of theta. And cos of 90 minus theta will be exactly the same as sine theta. I'll just show you using this triangle over here. So if that was theta, and we'll call this A, B, C for the sides, how are we going to find this other angle here? So that other angle there would be 180, take away the 90, like this angle, and then take away theta. 180 minus 90 is 90. So that angle there would be 90 minus theta. So this one in here is just theta, and the other one's 90. So then if you look at that, if you wanted to find cos of theta using the triangles, that triangle would be A over C. So what we're saying is cos of theta will be the same as sine of 90 minus theta. So go to the same triangle and look where 90 minus theta is. If I wanted to find sine, I need the opposite. So the opposite is A over the hypotenuse. It's opposite on hypotenuse. You'll notice it is just A over C, which is the same thing as cos theta. So you can conclude from that cos theta equals sine of 90 minus theta. And you could look at the same thing for cos of 90 minus theta. So cos of 90 minus theta would be B on C, and sine of theta will be opposite, which would be B on C. So cos and sine complement each other in a right angle triangle. So they are complementary angles complementary ratios in a right angle triangle. This being a 90-degree triangle. Okay, so there are two other trig ratios that relate. So one of them sine and cos. The other one is sec and cosec. So sec theta equals cosec 90 minus theta, and you can prove it in much the same way you did the other one. And cosec theta equals sec 90 minus theta. Okay, it's just really handy to know both of these, and you probably go on and you'll use them a little bit more later. Now it's just getting the basic rule. Tan and cot go together, so tan theta is the same as cot 90 minus theta, and cot theta is the same as tan 90 minus theta. So if you just quickly look at this triangle, that would be 90 minus theta, that's A, B, C. So if you want to get tan theta, well, tan theta would be B over A. And then you want to look at cot of the 90 minus theta. So that would also be B first over A, because you've got to do adjacent on opposite. But this one's, it will be, the cot one will be adjacent on opposite. So it would be A over B. And tan 90 minus theta would be the opposite on the adjacent, which is A over B. So they're exactly the same thing. So just as a little summary, sine goes with cos for complementary angles. sec goes with cosec, and cot goes with tan. So if you're given sine theta equals cos of 40, find theta, then basically to find theta, we know that theta plus 40, because cos and sine are complement, equals 90. So theta would have to be 90 minus 40, which is equal to 50 degrees. And that would work for any of them. We could go with sec. So sec theta equals cosec 55 degrees. So we know that theta plus 55 would be 90. So theta is 90 minus 55. So that's equal to 35 degrees.